In this video, we will talk about IB Math Past Paper, AA Standard Level, Paper 2, Time Zone 1, May 2021. Question 1, Part A. We want to integrate 6x plus 7. By the opposite process of differentiation, we add 1 to the index of x and then divide it by the index. For constant term, we just multiply it by x. For indefinite integral, remember to put c after you get the answer. Part B. f dot x is 6x plus 7, and f1.2 is 7.32. We try to find fx. So, by the result in A, we just need to substitute 1.2 for x and 7.32 for f. Then, we can solve this equation and get c equals negative 5.4. Remember, use calculator for paper 2. X and y are two parameters which can be modeled by the regression line. Y equals ax plus b. Part A. Just input the data to calculator, and we can find the values of a and b. Part B. We substitute 18 for x, and then we get 12.3 for y. Part C. We need to find the mean values of x and y. Again, calculator work. Part D. We need to draw a line of best fit. Remember, the line must pass through the mean point 15 and 11. Here, I show you an improper example. This line is drawn without ruler, so very ugly and score may be deducted in the real exam. Remember to draw your straight line by a ruler in the real exam. Question 3. The mass of a bag of sugar is modeled by a normal distribution with mean 1000 and standard deviation 3.5. It will be rejected if the mass is less than 995 grams. First, we let it to be x. Part A, we need to find the probability of x smaller than 995. By calculator, we get 0.0766. Part B. We need to estimate the number of bags rejected from a random sample of 100 bags. So, we just need to use the answer in Part A times 100, and we get 8. Part C. Given that the bag is not rejected, we need to find the probability that it has a mass greater than 1005 grams. So, by the formula of conditional probability, PA given B equals to PA intercept B over PB. It is just Px greater than 1005 over Px greater than 995. Finally, we get 0.0829. Question 3. A Ferris wheel with diameter 110 meters. The lowest point is 10 meters above the ground. The wheel starts moving with P at the lowest point and completes 1 revolution in 20 minutes. The height of P above the ground after T minutes is given by a function h. We need to find the unknown A, B, and C. Obviously, h is a periodic cosine function, so A is the amplitude, B is the angular speed, and C is the vertical translation. A is just the diameter of the wheel divided by 2. Be careful, as P moves from the lowest point, but cosine function starts from the highest point. We need to add a negative in front for vertical reflection. To get C, we need to consider the height of the middle point of the wheel. Add 10 to 55, which is 65. B is just 2 pi over the period 20, which is pi over 10. Question 5. We have the velocity function of a particle and a velocity time graph. Part A. We need to find the smallest value of t when the particle is at rest. That means we set velocity to be 0 and solve it. We get 6.74. Part B. We want to find the total distance. Displacement is the integral of velocity, and distance is the integral of absolute velocity. Calculator gives us 37. Part C. Find the acceleration when t equals 7. Acceleration is the derivative of velocity. We put 7 in and get 5.93. Question 6. Consider the expansion of this. And by given that the coefficient of x4 is 20412, we want to find n. First, we write down the general formula of the terms, and then we try to consider the term of x4. So, r needs to be 2. We substitute it back to the coefficient of the general formula above. We get this equation. You may simplify it or not. Finally, calculator tells us that n is 7. Question 7. Two people, A and B, also want to have $20,000 with originally $9,000 to invest. Part A. A invests her $9,000 with interest rate 7% PA, compounded annually. Find the value of the investment after 5 years. For this kind of questions, we can use financial function of our calculator, or using formula to do. This part, I just use formula. So, it is just the principal times 1 plus the interest rate to the power of 5. By calculator and correct to nearest $100, we get 12,600. Then, we want to find the number of years required for A to achieve her target. This time, I use financial function of the calculator. Set I to be 7, present value negative 9,000, future value 20,000, P per Y is 1, C per Y is 1, and we can get 12 years. Part B. B invests 9,000 with interest rate R% PA, compound monthly. R is set to be 2 decimal places. Find the minimum value of R for B to achieve her goal after 10 years. By calculator, N is 10, PV is negative 9,000, FV is 20,000, P per Y is 1, and C per Y is 12. Since it is compound monthly, so we get 8.02 for R. Part C. A third guy C also wants to achieve 20,000. He saves his money without interest, but each year he will add half of the amount of previous year to his account. We try to prove that he can never succeed. First, we need to realize that the money he adds every year is geometric sequence. So, the total amount in the account is geometric series. By the formula of geometric sum to infinity, U1 over 1 minus R, half, we can get 18000, which is lower than 20,000, so set. Then, we need to find the amount he needs to put into the account initially in order to reach his target after 5 years. By the formula of geometric sum, U1 times bracket 1 minus R to the power 5 over 1 minus R. Set it to be 20,000, solve it, and we get 10,323. Question 8. Everything is marked on the diagram. Theta is in radian and arc DE is 28 meters. Part A. We try to write R in terms of theta. Use the arc length formula. Radius R equals arc length 28 over the angle theta. Part B. So that the area of the horse can reach is this. That means the total area of this sector and this triangle. Sector area is equal to half theta times R squared. And the area of the triangle is half AB sine C. A and B are this side and this side. C is the angle between them. By part A, we can substitute 28 over theta for R, and the angle between these two sides is just pi minus theta. Also, we need to remember that sine pi minus theta is just sine theta. So, simplifying the things, we get the expression. Part C. The area is actually 460, and we try to find theta. Set the expression in Part B to be 460, and by the solving function of our calculator, we get 1.44. Part D. Find angle DAE. Note that this triangle is isosceles, so these two angles are the same. Therefore, exterior angle of triangle is just theta divided by 2, 0.720. Part E. We have a new diagram. C is due west of B. AC is 800 and bearing of B from A is 195 degrees. That means here is 195. Then, we need to find angle ABC. The most important thing for bearing question is that we better draw the north pole of the points we need to consider and use the property of parallel lines. So here is 195 minus 180, 15 degrees, and by alternate angles, here is also 15. Therefore, angle ABC is just 15 plus 90, 105 degrees. This question is tricky because for the previous part, it used radian but it suddenly changed to degree here. Then we want to find the length of the fence. One thing important to this part. We already find angle A in part D, so remember to mark it here. Then we have this pair of sine and angle, and we also have the opposite angle of the fence. We should use sine rule here. BC over sine 0.72 is equal to 800 over sine 105 degrees. Remember to change 105 degrees to radian before you input the things into your calculator. That is 1.833. Solve it and we get 546 meters. Question 9. Here is a function f, and we know that f intercepts y equals x at P. Part A. Find the x-coordinate of P. Just substitute x for y into f and solve it by calculator. Part B. Line L has the gradient -1, and it is a tangent to f at Q. We need to find the coordinates of Q, so we need to find the derivative of f and set it to be -1. Take natural log on both sides, making x to be the subject. We get 2 natural log 45. And then substitute it back to f. We get y equals 2. Here, the question is just testing you the rules of logarithm. Part C. Find the equation of L. As we know, the slope of L is -1. By y equals mx plus c, we have the following. And we just need to put point Q into the equation. And we can find c, as well as the equation of L. Part D. We need to find x-coordinate of the point L meets y equals x. So, just set them equal and solve it. Then, we need to find the area of A shown by the graph. Obviously, we need to use definite integral for this kind of questions. We need to check which line is on top and which line is at the bottom. We need to be careful, since there are more than 2 lines here. We cut it in this way. For the left part, orange line y equals x is on top and L is at the bottom. And x is from the x-coordinate of point A to P. For the right part, red line function f is on top and L is at the bottom, which is from the x-coordinate of P to Q. Finally, input this complicated thing into our calculator. We get 1.52. After a lot of work, we still have part E. We have a new graph with f and its inverse. The line L is tangent to both of them. Now, we need to find the area enclosed by them. Here, it is not testing us computation, but the knowledge towards inverse function. Inverse function is just the reflection of the original function by y equals x. So, the areas of these two parts are the same, and the colored part is just the answer we find in part D. So, the final answer is just a double, 3.04. We have gone through all the questions in this paper already. Thank you for watching. If you like it or want to know more, please like and subscribe my channel. Bye bye.